Well, we've been talking about Ka, the equilibrium constant for weak acids. So it makes sense that we should discuss briefly what is Kb. Kb is the equilibrium constant for weak bases. So it works pretty much the same, but I thought it would be fitting for us to take a look. All right, so one of the weak bases that's very, very common is ammonia. When ammonia is put in water, it's very, very soluble because it hydrogen bonds to the water, and it stays mostly as ammonia molecules. However, some of them ionize, they react with the water, they take a hydrogen from the water, forming hydroxide and ammonium. A lot of students forget the names of these ions. That's ammonium, and this is ammonia. So let's take a look at the equilibrium expression for this weak base. We would take the ammonium over the hydroxide, times hydroxide, those are the two products, over the reactant ammonia. So when the pH was measured, and we measured 0.10 molar solution, this is a weak base. If it were a strong base, then the pH would be 13. But in this case, we're measuring a weak base. So our pH that I measured is 10.97. Again, that measures hydronium. It's measuring hydrogen, not hydroxide. So we're not measuring POH, we're measuring pH. So now we have this tremendously small amount of hydronium. So 10 to the minus 10.97 is 1.1 times 10 to the minus 11 molar. That's incredibly small. We should remember that always, when we take the hydroxide times the hydronium, it always equals 10 to the minus 14. So the hydroxide is going to equal 10 to the minus 14 divided by the hydronium, which we just measured. And we get 9.1 times 10 to the minus 4th molar, and that is going to be the hydroxide. Okay, so let's write out our equilibrium equation. Ammonia plus water, there's an equilibrium set up, and we get ammonium ions and some hydroxide. Again, it's a weak base, so we get a little bit. Our initial concentration was 0.10 molar. Again, water doesn't come into play. Both of these started out at 0, went up by the amount of hydroxide. These ice tables sure are useful ways of calculating. Okay, we've already got our expression, so I'm not going to copy that, but these are the same, so we'll square them. and we get 8.3 times 10 to the minus 6. That's the experimental KB of ammonia.